Nano fam, welcome back. Another RsNano developer stream. Hey LFLF, hey Jubu. So this was another exciting week. So I just have to reduce volume, it's too loud. 14:01, rusty evening everyone. Nano is the light, as Wenderson always says. Let me just add you all to the spinner wheel. The timer is already running. So LFLF, we've got Jubo, we've got 14:01. Yeah, so if you want to take part in the giveaway, just post your Nano address in chat, or if you are in the address book already, just say hi. And yeah, Nano is the light. Hi, Pies. Okay, so let's add you too. Good. Yeah, so to all the new viewers, this stream is about the RsNano project, where we port the Nano node from C++ to Rust. And I've been working on this for 2 years, or more than 2 years now. And LFLF, he already updated the graph. And we are making a lot of progress, and we are even higher now. So I ported more code already. So let's just check the current number. So is this what is a better font size for you guys? Is this too big? 49.11%. So, and this is very pessimistic. So actually, we are a lot closer now to a full Rust node than ever before. Let's just check the current state. Colin, hey, yeah, the nanomag. I got this from my brother as a birthday gift 2 years ago, I think. LFLF says, I need a few minutes to update. It's still not home. Yeah, don't worry. Just wanted to show the current percentage. Yeah, so last week was very, very productive again. I have almost all of the node dependencies now in Rust. So let's go to the node HPP and let's oh, okay, this font size is a little bit too big for me. Can't see anything. So as you can see here, these are all the dependencies of the node class, and they are all ported now, except for just 2 are still missing, and they are not very important really. So the one that is still not ported is the port mapping, and this is a helper class so that the node knows its external IP address. And this uses, let's have a quick look at it. This uses UPnP stuff, and I have to find a UPnP crate for Rust that works in a similar way, and I haven't done that yet. And the other one that is still not ported is the what was the name? The what was the name? The work factory. Yeah, the distributed work factory. And this is a class that talks to a work server. So if we don't want to create the proof of work locally with the CPU or with the graphics card, I know. So this just makes RPC calls to a work server to outsource the proof of work generation. And this is also not ported yet. And these are the only 2 classes, the only 2 that are not in Rust yet. So this is not a lot of work left here. So maybe maybe next week we will have a full... yeah, no, I shouldn't be so optimistic. So never trust a programmer when he says a date. Yeah. Hi, Craptor. So let's add you to the wheel too. Yeah, so not much left. So just these two classes, and yeah, let's just if you listened to today's dev meeting, you already know what the current state is. But if you haven't listened to the dev meeting, let's just go to the Discord, because here I also posted a list of everything that I ported last week. So as you can see, a lot of classes that I ported last week, and basically that concludes the bootstrapping. So now all of the bootstrapping, not just the bootstrapping servers, but also the bootstrapping clients and the bootstrap management, like connections and initiator and bootstrap attempts, everything is now in Rust. And also the network stuff, the threads that keep sending keep lives and merge new nodes and the network processing threads, everything is now in Rust. RsNano ist das Licht. Hello. Let's also put you on the wheel. Wenderson. 3 minutes for the next Bitcoin block. Yeah, so that's the current state. And my plan is to port these two last missing classes, and then to port the node class. And that is a huge milestone then. So I've been working towards this milestone for over 2 years now, and after reaching that milestone, my focus will not be on porting so much, but more on refactoring the code and writing unit tests. Craptor says, hopefully this is not the rigged wheel. Worked well for me last time. It is the rigged wheel. I'm sorry, Craptor. The other wheel that I used, it doesn't load anymore. So we have to go back to the old wheel, the rigged one. I'm sorry. So for today, I thought I would clean up code. I don't have a specific goal. Maybe we can continue working on the WebSocket stuff, like in the last stream. Or guys, if there's anything that interests you, you can also suggest components that we work on, because we have to refactor everything eventually. I ported the code as it is, and I made it worse often, because code quality was not my focus. My focus was just to bring it to Rust first, and my goal is then to clean it up. So you know the saying, make it work, make it nice, make it fast. And I'm still in the make it work phase, and I'm slowly migrating to the make it nice phase. So yeah, so if there's any part of the node that you find interesting, you can also write it in chat, and maybe we clean it. We focus our cleanup on that part then. And if you're fine with working with the WebSockets, then let's clean up the WebSocket code. LFLF says, looking forward to the unit tests a lot. Oh yeah, that will be difficult. I hope I can finally understand a bit more then. Yeah, me too. I'm also learning about the node by writing tests. Because like I said last time, just by porting the code, you don't actually learn that much about the code. It's just like driving the car with a navigation system, and it says like 10 meters left and 100 meters right, and you don't, if you just go left and right and you don't know the bigger plan behind the navigation, yeah, you don't learn much about about the way. And Same with porting code. But with writing tests, that really helps with understanding. Niyush, hello. Are you in the address book? I think so. Let me check. Address book. Yes, you are. So let's put you on the wheel. Okay, so just in time. Oh, Bitcoin block appeared. The first giveaway already. So the first nano for you, News. Just in time, and then you win the first nano. That's great. 1 nano for you. All right. So, what else? Let me check. So, yeah, maybe. So maybe let's start with the WebSocket corrupter. No spinning wheel music. No music. Sorry. Yeah. So let's start with the WebSockets, and if the WebSocket stuff is if we are stuck, we can just move to any other place, because all of the code needs a makeover. So if you want to help, and if you know a bit of Rust, maybe this is a better task to contribute. It's easier than porting maybe, and there's just basically all files need a bit of a refactor. So if you want to help, just pick a file that is just very hard to read, with huge functions and a lot of dependencies, and make small improvements to it, and open a pull request. So that's also more interesting work than porting code. Okay, yeah. So let's go to the WebSocket code where we left last time, and I worked a little bit more on it. Not much, but a little bit more. So I removed a bit of I don't even know what I did. I just know that I refactored this a little bit to make it simpler. Did I do this on stream last time? I don't think so. Like using real structs for the messages and using serialization. I don't know, but I do remember that I changed everything to string just to stay compatible with the C++ version. The C++ version returns all data as strings, so it doesn't use Boolean types or integer types from like we would expect in normal JSON, but everything is strings. So I copied this behavior here and I made everything strings, just to stay compatible with the C++ node. And yeah, we can decide on breaking this compatibility later. But right now I don't want to break compatibility. And then I worked more on these message builders, simplified the code a bit, and I think we can just continue there, because I see that these functions, they return results now, but they can never fail anymore. So they could fail in the past when we used the property tree wrappers, but now they just create simple structs that will be serialized, and they can never fail anymore. So let's remove the results. So just small updates that in very small steps make the code a little bit better, and those steps accumulate, and when we just have hundreds and hundreds of or thousands of steps that make the code a little bit better, then the code will be better by a lot eventually. So let's remove the result. And let's go to the place that uses this function. And the place is bootstrap attempt. So here we can remove the question mark operator here. And bootstrap attempt. I think we can even inline this bootstrap started into this struct, into the bootstrap attempt, because this is the only place that uses it. And I think we can also, we don't need these extra braces. And we can also inline the topic. Oh, wrong. Inline. And we can inline the message. Yeah, so this outgoing message envelope is something that I refactored after the stream. So this is the WebSocket messages that get sent back to the client. They have these fields here, like the topic and the time, for example, and then the actual message. And I just created a struct for this, and I called this outgoing message envelope, because this is, yeah, I thought this was a better name. It was like an envelope for outgoing messages. And so we returned that, and the outgoing message envelope in the constructor. Did you reset? No, of course I didn't. I didn't reset the timer. Thanks, Coptor. So it's running now? Yeah, it's running now. So, yeah, so this initializes the outgoing message with some values, and the ID is never set. No, the ID is set in the ACK message. Okay. Yeah, that makes sense, because only when we acknowledge messages we know about an ID. So I created these two constructor functions to create the outgoing message envelope. And now I want to... Yeah, I want to inline this. This is only used here, so let's move this function into the bootstrap attempts. Let's move it here and delete it here. Import the missing dependencies at the topic and the bootstrap started. Why can't it import bootstrap started? Is that maybe not public? Bootstrap started. Oh, those structs are all private. Let's make them public. So bootstrap started, bootstrap exited. And let's also move that over to bootstrap attempt. Should we move it over? Let's think about this. Yeah, I want to move it over because I want to keep all of the code close where it's used, and this has only one usage. So this has only one usage, and that usage is over at bootstrap attempts. So I want to use it there, move it there. Let's move it there. Bootstrap attempt. Let's move it there. Bootstrap started. Okay. Bootstrap started. So here we don't say message builder bootstrap started, but we just say bootstrap started self. Ooh. And yeah, so maybe let's draw the current design. Maybe that helps. Can we draw? Oh, I think I deleted. I think I deleted what we drew last time. Yeah, I deleted that. It was in here. Yeah. Oh yeah, so I deleted it to create this diagram. So this is almost where we're at. This is the node in Rust, all of its dependencies in Rust. And what's still in C++ is the command line interface, the RPC server, and the unit tests. So we are almost there. Just 2 classes missing and the node class. Yeah, so let's delete that. And let's draw what the current design. So currently all of the bootstrap messages are being created by the bootstrap message. What was the name? Message builder. So we have this message. Oh, we have this message builder, and then we have in this our case we have the bootstrap attempts struct attempts that uses the message builder to create the started and the stopped message, and the reason I'm just currently moving the started and the stopped message and so on from the message builder into the bootstrap attempts is this. The message builder, it has all of these build functions like bootstrap started, bootstrap exited, and many more. And they are just being used by one instance. So the bootstrap attempts uses these two, and other places use the other functions. And so if the different places use all different functions, I think that we should not have the builder as a central magnet, dependency magnet here. Even though there is not much dependencies going on, but I think I want to inline the messages to the only user of those function calls, just to bring code together that belongs together, basically. NardoETH, spring cleaning. Hey, NardoETH, I think I did not put you on the wheel yet. No. Spring cleaning. NardoETH. So, yeah, but I'm not really sure here if this is a good idea or not, but just that you know what my thinking is. So, this is in the solid principles from clean code. There is the I in solid stands for interface segregation principle, and it says that when we have an interface, we want to use all of its functions and not just part of its functions. And if we use only part of the functions and not the other functions, then that interface is too big and we should split it up. So that's why I'm thinking about moving those factory functions out of here and into the place where we use them. Let me know if you have a different opinion here. So bootstrap attempts. So where was no? It wasn't bootstrap attempt. So here we have it now inlined. So maybe. Mode. Mode is a string. Self.mode text. Used by self.mode. So because this is from self, we don't even have to pass it as an argument, really. We can, the mode, we can just say self dot. Oh, we don't have a self. Self.mode text. Then we don't. So maybe I'm also going to revert this. I'm just playing around a bit. Just want to see where we end up here. So ID, what is ID? Okay, ID, we also have it as a field. So we could say self.id. So when I try to clean up code, it doesn't always work out well. So sometimes I try stuff and then it turns out badly and then I just revert it. So don't be surprised if this happens here. 1401 says, do you take notes of these structural changes, or how will you deal with these differences upstream when future PRs of the C++ codebase use the old structures? That is a good question, and currently I'm not taking notes. I just rely on memory, and this strategy is not good. So, but on the other hand, documenting all of the structural changes that I made already, that would be, it would be a book. Usually I just try to find code by text search. So I know where stuff is mostly, and I know the functions that are called, and so I can just find the places in the code by find usage, or by searching for certain comments or for certain log messages or something like that. I mean, documenting all of the changes I make is that would be a huge task, and I don't think that it would be that helpful. So, because where should I look there? What do you guys think would be a good strategy here? Yeah, so the ID is not needed anymore. This is now self. This is now dot like that. And node. Maybe in 14.1 says maybe in comments in the code, like function xyz move to. Yeah, oh, that would also be a lot of comments. That would be a lot of comments. And it's not just like functions move to, I change functions a lot also. I split them up, I merge them, I think it's impossible to keep track of that. But it's a good question. So I think I need a strategy when it turns out to be a problem. And so far I don't see it as a problem so far. So when upstream code changes, I always find it pretty quickly in the Rust code. And even if it is in different places and the functions are named differently, it's not really a problem right now. Yeah, I see. Only solution to commit the full code by stripping. Oh no, that's impossible. It's too big for that. But I do it with text search, function search, or just clicking through the functions. Bootstrap started. Yeah, so let's also move the bootstrap exited into here. That is also in messages. And let's just check that this has only one usage. Yeah, only one usage in the drop of bootstrap attempt. So I want to move that here. And maybe let's move it directly below the bootstrap started function. Bootstrap exited. And we also have to move the bootstrap exited struct. There it is. Yeah, but generally speaking, I like to have code that belongs together, very close together, and that's why I'm moving those structs out of the message file, and I move it into the bootstrap attempt file. So okay, so this also returns a result. We don't need a result. We don't need the ID because the ID is a field. We don't need the mode because we have the mode text function in here. What about the duration? Total blocks, okay. And now let's remove the OK. Let's inline the topic. Let's inline the message. And let's remove the extra braces. And now let's use this new bootstrap exited function here. So self.bootstrap exited, no ID, no mode, just duration and no unwrap at the end. It can never fail. So duration and total blocks. Let's also remove these arguments because the exited can just look them up by itself. So this is self.totalblocks.load. Ordering. I always pick sequential consistent because I don't want to take time to yeah, optimize the last nanosecond out of it. Timer again. Craptor, sorry. I'm really tired today. Sorry, that's why I make these mistakes. I didn't sleep much last night. So, so total blocks and duration was coming from where? Oh, we have it here, duration. So we can say duration is self.duration as seconds. And this doesn't need to be pub. let's go down to the drop and let's remove all of these arguments. Yeah. Okay. Craptor says, will you not port unit tests from C++? You're gonna write them from scratch? Oh, I will not keep the tests as they are. The problem that I see with the current state of the tests is that almost all tests are not really unit tests, but let's call them integration tests or system tests. So they test behavior by running the full nano node, and most of the times even multiple nano nodes. And I don't want to keep the tests like that because integration tests are slow and brittle and hard to write and hard to read. There are also good tests. For example, where was it? Let me think. I recently stumbled upon really good, really well written unit tests in the C++ code base. But where was it? Where was it? I think it had to do with the ascending bootstrapper. Just let's make a quick detour. I think it had something to do with the ascending bootstrapper. Was it account sets? I think it was account sets. Yeah, let's make a quick detour, chat. Let's go to the official repository. Oh, by the way, then the RsNano repository changed. It was under Sympago RsNano node, and now it's under RsNano node, RsNano node. So let's go to the official code base, and I think it was in the account sets. Or the bootstrap ascending. Core tests. So these are the C++ tests, and it wasn't them, but they are not really that bad. Okay, I don't remember, but so most of the tests in the C++ code base, they run a full node, and then they test a tiny little detail or something. And I want to write unit tests where I don't have to run a full node. I just want to focus the test on a sub part of the system, on a unit. So it's a unit test. I want to focus the tests on a unit. And not on the whole node. But obviously, I want to keep a small amount of integration tests, because unit tests alone are usually not enough. So just a small amount of integration tests, and I want to write unit tests from scratch, and I want to replace most of the integration tests with actual unit tests. And I want to write the unit tests with the nullable patterns from James Shore, and I want to split the code into the A-frame architecture from James Shore. Craptor says, how will these tests help developing Nano? What can you figure out by doing the unit tests? So usually tests that are really, really fast, they help when you work test-driven, and that's something that I prefer to do. And you can't work effectively in a test-driven way when the tests are slow and flaky. So they will help me because that's the way I like to work. And I think these tests will also help new people who want to help with the project, because they serve as a kind of documentation. So if you don't know what a class does and the unit tests are written well, yeah, you can use the test as documentation. So where were we? We were at the bootstrap attempts. Yeah, so okay, we inlined that. So let's go back to the message builder and let's have a look at the other functions here. So they all have this extra curly brace that is not needed anymore. Let's inline the topic. Let's remove the result, because this also can't fail anymore. And telemetry received, who creates that? Okay, we have one usage in the WebSocket server, and we have one foreign function interface function here. And maybe we don't need that anymore, because I think I ported everything. So maybe this is just being used in tests, or maybe it's not being used at all. Let's do a text search for this function name. Builder telemetry received. So this is the C++ place where we use it. And let's do let's search for usages of that function. Yeah, I was right. It is not being used anymore. So we can delete this. Let's delete this. And let's delete this. And now let's delete the FFI function. And now let's jump back to the message builder. And now we only have one usage of this function, and it is in the file WebSocket server. So let's move it there. Let's move it to where we use it. And what is this? Okay, this is just a function, so let's also keep it here as just a function. And this has to import telemetry data. And socket address is version 6. And outgoing message envelope. And telemetry received. Oh yeah, we have to move the telemetry received to that file too. So let's move it here. What else do we need? Unix epoch, not imported yet. We have to import SERDI serialize. And we have to remove the unwrap. And this is not in the message builder anymore. This is a local function now. Yeah. Should we inline the message? Let's have a look how it would look. Inline variable. Yeah, I think it's okay. And what's nice about these functions is that they are not using any infrastructure. Yeah, they don't use any infrastructure, so functions like these are very easy to unit test because they just depend on the inputs that you give them. So you could write unit tests for this very easily by just providing some test data. and just asserting on the result. And most of the unit tests should be like that. Oh, I did not hear. Did you hear the Bitcoin block sound? Let's spin the wheel. Hey, Jubu. Congratulations for winning 1 nano. There you go. The big Craptor says the Bitcoin block sound has been gone for some time. That is strange. Let me check, but... Okay, let me click the test button. Did you hear it? No. I don't hear it. Select sound. Maybe the sound. No, the sound file is here. I don't know. Okay. So telemetry received. We have that here. Let's go back to message file. I just want to do this for all the other messages too. So address and telemetry data. Oh. Topic. Okay. Incoming message. Okay. So started election, stopped election. Message builder. So new block arrived. So here we have one real usage in the Rust code and one FFI function. So maybe we can also delete the FFI function. Let's search for builder. Oh, the builder new block arrive. And who calls this function? No one calls this function. So let's delete that. And let's delete the FFI function. And now let's go back to here. Now we have only one real usage. And that real usage is in process live dispatcher. What does process live dispatcher do? I have no idea. Observes confirmed blocks and dispatches the process live function. Okay. It observes confirmed blocks and dispatches the process live function. And what is the process live function? Hey Colin, you're still watching. Deleting code is the best. Oh yeah, I love deleting code. I love it so much. It's way more fun than writing code. Hey, while you're here, what is the process live dispatcher doing? Inspect process live. If the dependents are confirmed, it activates the block. Okay. Ah, okay. So when the new block is coming in, into the node, and the dependents are confirmed, then it activates the block for in the active election container. Okay, and it also sends a WebSocket message which is called new block arrived, and I want to move this to the place where it's used. So let's cut it here. Let's paste it here. And this does not have to be part of the process live dispatcher. Let's just have it as a just as a function. So outgoing message envelope. So we need. Oh, okay, so this still uses the 30 property tree. I want to delete this too as soon as I can, because this is just a relic from the past when all of the JSON was generated by the C++ property tree classes. Colin says it's executed after a block is processed. It activates the block and calls the WebSocket notification. Okay. So new block arrived, so this creates our new block arrived message, and yeah, so this still uses the 30 property tree. So this is something I wrote as a wrapper, and I want to get rid of it. Can I do this now? Maybe not, because serialized JSON is a function of block. And I think this, yeah, this is still used a lot. Yeah, I'm not going down that road. Not yet. I will delete it eventually, but not today. So let's keep it like it is. And we have the new block arrived here, and we don't need the message builder anymore. So I think, yeah, by moving those factory functions out of the centralized message builder, we are also making the design a little bit more extendable or more abstract, because so this is how it was before, and we had one class that contained all the messages that could be sent, and whenever we wanted to add a new message to be sent, we would have to change this central class, and that would mean that we have to recompile all dependencies, and this was not really extendable without having an effect on all of its dependencies. So when we move these functions out of here and we move them to the only place where they are used, we don't have a central dependency anymore that couples all of those parts together. So that was my thinking here, but I could be wrong. I'm not 100% sure this is the right way. Yeah, but I want to keep going. Let's see where this leads us. Okay, new block arrived. I also want to maybe rename this. Yeah, let's rename this to new block arrived message. This, yeah, so WebSocket broadcast new block arrived message, and we have it down there, and we don't have a data structure that we also have to copy here, so this should be good. Let's go back to WebSocket, and let's do the same for started election. Okay, same procedure. Let's first remove the FFI function if we can. What was the name? Started election. There it is. Do we have usages? Nope, we don't, so we can delete it. And let's delete that. Let's delete the FFI function. And let's move the started election to where? To the WebSocket server. Down there. Let's remove the result. This can't fail. And the extra braces and the OK. And okay, started election struct, we have to move that one too. So started election struct, let's go there. And we need to import the block hash. And let's inline topic and let's inline the message. Okay, and now we can use this new started election function here. And we can remove the unwrap. So slowly our code is getting a little bit simpler. And these small improvements, they really add up. So you don't notice much of a difference in the beginning, but if you just keep improving the code in small steps, yeah, it really makes a difference. So let's go back to message. Let's remove the next one, election, stopped election. Yeah, there's an FFI function. And I hope that no one uses the C++ version of this function anymore. No, so let's delete it. Let's delete the computation. And let's delete the FFI function. That one goes to the WebSocket. Oh, sorry, wrong file. WebSocket server. Okay. Now result. And oh, election was stopped. No, wrong file. Where is the stopped struct? Stopped election. Okay, inlining. And let's use it. Okay. Good. Next one. Next one is block confirmed. Oh. Oh my. What is that? Okay, that is huge. That is way too big for my taste. Let's inline that. Maybe we can split this up. And also, it has a lot of arguments here. And can we rename them so that... Oh, I can't? Why does rename work? So I want to rename them so that there's no A suffix. Why doesn't that work with LSP anymore? And result? Can we remove the result? Can we remove the result? Yeah, so block serialized JSON. So block serialization actually cannot fail. So And this will be obvious once we can delete the 30 property tree wrapper. So I want to just call unwrap here. Because I know that it can't fail really, and when we delete the 30 property tree, then we don't even need to unwrap anymore. Oh, there's a naming conflict. Ah, I renamed blocked. Let's undo. Yes. Oh no, this isn't block. No, let's redo. What's wrong here? Why can't I redo these things anymore? Block. There was a block variable down there, wasn't there? No? Yeah, here. What is this? Option value. Block. Let's rename this to... What is this? This is the JSON. This is the JSON block. Renames don't work anymore. Maybe I should restart. Vim. Let's call this block JSON. And now let's one more time. Now, let's first remove the result. And let's add the unwraps again. Okay. And can we inline this? Yeah, we can. And now I want to move the block confirmed to the listener, because that is where we use it. So let's cut it. Let's go to the listener. Let's just paste it at the bottom. So block confirmed is now just a function. But I also want to rename it to block confirmed message. Oh yeah, and we can delete the unwrap. So let's do... Oh, there's imports missing. Yeah. Import. And what is that? JSON vote summary. Is that a struct from this file? JSON vote summary? Yeah. So let's move that. Okay, so we have to move a couple of structs here. So the JSON vote summary, also the block confirmed. And the JSON sideband. This is the JSON, so the JSON value. Collection info, is that here? Oh, a lot of structs that go into, that move from this file to that file. Winderson says, real Colin is the life. So you're asking If this is the real Colin, yes, it is. Windows, we should say Nano is the light to him. We need to know our world. I think Colin knows that Nano is the light. All right, so do we have everything that we need now? No, the sturdy property tree. We have to import the sturdy property tree. And what else? Unix epoch. What else? Unused import message builder. Okay. And one last error. Add function. So we have to import another missing trait. And that was it. So now that is error free. Okay. Next one is, or should we take more time and try to make this huge factory function here, block confirmed, smaller? Let's rename it first. Block confirmed message. And can I now rename these? No. Yeah, I can. So this is block A, so let's just call it block. And account, let's rename it to account. Amount. Include block. Action status. So these underscore A suffixes are the coding style of the C++ code base, and I just copied it. But now I want to remove that. Why is this message, this function so big? What does it do? What is that? Confirmation type. Can we extract that? I haven't figured out how I can extract functions with the help of the LSP. So this is the confirmation type. So let's maybe move that out. Election status type. Election status type. We can make this a function of election status type. Stopped. Should we do that? Probably not. Because is this an implementation detail of the WebSocket messages? That's the question. I'm this unknown. Yeah, but this unknown text should actually never happen. So if the code is bug-free, this unknown will never be reached. Because we only send block confirmed messages if the election is either active confirmed quorum or active confirmation hide or inactive but it can never be what do we have, ongoing or stopped, because if it was ongoing or stopped it would not be confirmed. So let's yeah, I want to make this a function of election status type. So do you still see that here? Yeah. So, or maybe let's switch the windows. So let's say impl election status type. And let's add a... Let's add an str function. And this will return a static str. Static str. And now we can just copy that over to the election status type. This can all be self. Oh. That was wrong. Okay, so now... No, self doesn't... Oh, match is missing. Yeah, and I also want to add the other ones too. Even though it doesn't matter in this case. But I just for completeness sake. So stopped and ongoing. Okay. And one nice thing about Rust is if we add another status type here, we will get a compiler error if we forget to handle it in this match down there. So that is foolproof. Jandu16 asks, what are you doing with crypto with Rust? We are porting the C++ nano node from C++ to Rust, and the project is called RsNano. So go to rsnano.com and there you can find everything about it. What is NanoNode? Yeah, go to nano.org. It's the super fast and feeless and eco-friendly cryptocurrency. Porting projects are fun. It is fun, but it's also a lot of boring work sometimes. I've been working on this for over 2 years now, and I am so close, like really, really close to having it in Rust, the main component, the node itself. 2 years, yeah, 2 years. But almost done. I'm almost done. I thought it was a 1 week project. Yeah, 1 week would be a bit short for such a big code base. Maybe a future AI could do it in one week. So, okay, so I have this new helper function now, and now I can use it here. I can just say election status as str. So, slowly but surely, extracting functions, making this code a bit smaller. And I really like small functions. So did you watch the interesting interview of the Primogen and Uncle Martin, Uncle Bob? And I know that the Primogen, he does not like small functions at all. But I think that Uncle Bob made a really good case in the interview for why small functions are preferable. Cropter says 1 week left from now, maybe. Yeah, and this is actually a good estimate because just 2 classes missing, the port and then the node class itself. So that is not much work left anymore. Chandler says, I hate AI. Really, why do you hate AI? It will revolutionize everything. Let election info. So this is, what is this? What is going on here? So what does this block do? It creates election info. And what does this block do? Votes. Okay, so if... Okay, so there's a flag here. So if we want to include the votes, then it creates... What does this create here? JSON vote summary. And this is election votes. So maybe we can move this out of here. Oh, so many chat messages. Oh, and there's a Bitcoin block appeared. Man, I don't... Chat, you have to help me. I don't get a sound when the timer is up. So let's just spin this now and read the chat messages. Jane says, I don't know that they had a dead people. What do you mean with dead people? It shows strength to continue a project for 2 years. Yeah, but yeah, I'm continuing it because I really believe that Nano is a game changer in the crypto industry, and it is fun. Yeah, it is so much fun. Janda says, what does Uncle Bob think about AI? I don't know. You have to ask him. It's going to make your life ugly? Why do you think that? Hey, Jubu, you won. Oh, it's locked again. Let's unlock. Okay, good. So... Jen says, I'm in a third world country. And why do you think that the AI will make your life worse? Oh no, I closed the Bitcoin timer. 1 second. And here, yeah. Okay, sorry. Okay. Yeah, so this part here creates election votes. So these we get them in here. It just iterates through them and creates the JSON vote summary. Let's start small, because I think we can just extract this part, which converts what is V? Which converts a vote with weight info into a JSON vote summary. So let's extract this part. JSON vote summary. So I want to copy that. I want to go to the JSON vote summary. And then I want to say impl from what was vote with weight info? For JSON vote summary. And this returns okay. And now we can use this conversion function here. So instead of that, we can just say v.into. And that simplifies it a little bit. And election info. So this creates election status. And what about the votes? Include election info with votes. Maybe we can extract this as a function. Ginger says, I can't use current time to make myself better since I can't afford a lot of things. Now AI comes along and takes away what job I do. I guess I have back issue and is another problem. Ah, okay. I can't. Yeah, I don't have any advice. Yeah, I want to copy this. And I want to create a function that creates the election info from... I can't really use the from trait because it has more options here. It has a bool flag. It has a bool flag here. So let's just create a conversion function. And yeah, let's just copy that. Let's just copy that and let's create a conversion function for the election info. And how do we call that? Into or get into create election info. Into election info. And we need a flag here that says include election info with votes. So this says whether the votes, we have to include the votes. And this is an election status, okay. So we need the election status. And we need a bool set that says include votes. So this then becomes to if include votes. Oh no, the votes are extra. The votes are an extra field. David 1998 says, is that Vim and Rust that I'm seeing? Yes, that's Vim and Rust. We are working on migrating a large C++ code base from C++ to Rust. RsNano. This is the project, rsnano.com. Just go to the site and there you can read everything about it. So 4 minutes for the next Bitcoin block. If you want to take part in the giveaway, just post your nano address in chat. And we give away, or I give away, 1 nano every 10 minutes. So, you know, I do want to implement the from trait here. Yeah, I do. So let's just ignore this include votes stuff. Sorry for being ignorant. By nano, you don't mean editor, right? No. Yeah, so that is maybe a confusion, bit of a confusion. There is an editor called Nano, and there's a cryptocurrency called Nano. And we are working on the cryptocurrency called Nano, which the node is written in C++. It's, I don't know, a bit more than 100,000 lines of code, and we are bringing that to Rust, and I'm almost there that the node itself, without the RPC server is fully in Rust. Wenderson says, congratulations, Gustav. You received 3 nanos for your excellent job. Oh, you sent me a donation. Oh, I wanted to include the nano donation notifications for Twitch. Let me check. Let me check. Where is my Natrium? What? Oh, this is maybe the wrong account. I have too many accounts on my Natrium. Ooh. Oh, I don't know. I don't know. Yeah, let's get on with it. Wenderson says, I really enjoyed. And DJ with 1998 says, I highly respect Rust as a language, but it's too complex for me. I stick to Go. Yeah, it is complex, and you need a lot of time to get into it. Oh, you sent to this 1T6F. Which one is it? Which one is it? This is not that one. I have too many addresses. Is it that one? No. I don't know which one it is. Or did you send it to this to my Nord? Oh yeah, you sent it to this account. Thanks, Wenderson. Thank you so much. It even says your name because you're in my address book. Thank you, Wenderson. Thank you so much. Yeah, it's the same address. So this is just I don't use this address that I use for sending out nanos. This is just a temporary wallet for me. Okay, so where was I? Yeah, I wanted to implement the from trait. So impl from and from election status or what is the result election info? So now let's ignore the votes and let's ignore that and let's just move all of that here. And election status, let's rename election status with let's rename it with value. And votes will be none. And now we can use this. We can use this here. We can say election info is election status. And how do we do this? Election info from election status, and then we just change the votes. Something like that. Yeah. And the votes, yeah, so can we maybe let's still move this into its own function. Chat, help me. I forgot to restart the timer again. Okay, now it's running. Okay, so the next step would be should we extract this? What is that here? If options include election info or options include election info with votes. And we create the election info. Yeah, let's move that into that function that I talked about earlier, into election info. Okay. And it will take the vote with weight info. No, not the vote, sorry. Where am I? Election status. It will take the election status. Status, and it will take the flag that says include votes. And it will return an election info. Like that. So if include votes, what are the votes? Vote with election and weight info. We could actually turn this into an option. Maybe this doesn't buy us anything. Maybe I should not do that. Yeah, I don't, maybe let's backstep here. Maybe this isn't worth it. No, this isn't. This isn't helping much. I don't want to do this. I don't think we gain much by extracting that. But maybe we could simplify this a little bit by moving it into here, and then we just say if options include then we say info.votes is that. And then we can delete the else case. So a bit smaller now, a little bit simpler. Okay, so the confirmation type, I think we can inline this because, yeah, we only use it down there. So let's inline that. What is this here? If include block. Okay, so this 30 property tree. If subtype, what is subtype? Oh, we get the subtype in here, and this is being added. Ooh. Sideband info. Let's do the simple stuff first. So the sideband we can also move out of here and into from trait implementation. So import from sideband, block sideband, or JSON sideband. And let's add all that code here, and this just becomes simpler now. So we can use this from sideband. Now, where is the sideband? Down there? So we can say block the sideband unwrap into, and let's delete all of that. It's still ugly, but it's getting better in small steps. And maybe we get better ideas if we just keep improving it in very small steps and things become more clear. So what is that? That's a sideband. It's only used down there. I don't want to make more changes now. I think it's a little bit better than it was before. Yeah, what about that one? Yeah, maybe that one. Maybe that block here. What does it do? It takes a block? Oh, okay, no, because of the subtype. This is an extra argument. Why do we get the subtype here as a string? Who calls this? Let's check. The subtype. Where is it? Subtype here. Where does this subtype come from? Broadcast confirmation? Okay. Okay, I'm not going to dig down here. This seems complex. No. Let's keep it like it is. And let's go back to the messages, the WebSocket messages. And let's continue our work here, where we move these message builder factory functions out of here. So that is in the FFI part. And builder vote, no. Builder vote received. Can we delete this? No, we can't. There's actually a unit test that uses it. Oh. Oh, that's bad. Okay. Vote received. But maybe we can just change the FFI function so that it does not access the message builder. Yeah, let's do that. Or let's refactor this first. Let's remove the result. And also let's remove the result here in the FFI function. And yeah, we use it in WebSocket server. So I want to cut it here and paste it into the WebSocket server. And I want to keep it public because then we can use it from the FFI part. So we need vote code, and we need vote received. Struct vote received. So let's inline that. Vote received is here, and we can delete the unwrap. Oh, what happened? What happened? Wenderson says, I think the more Node Nano implementations in different languages, the ecosystem wins because it brings the developers of each language together. Yeah, it is good to have multiple implementations because the network should be more resilient than. So a bug in one node implementation should optimally not be there in another implementation. And yeah, it's just good if more eyes are on the code. So, and if you have multiple implementations, maybe you find bugs faster. Giveaway time. Thanks, Croptor. I didn't hear it. How many nanos have we given away so far? I think we are behind today. Jubu again. Send one nano. What's going on here? Is that my Wi-Fi being slow? Preparing send. Preparing transaction? What's going on? Okay, now. I'm spoiled by Nano, so I don't like to wait at all. It's rigged, says Craptor. Yeah, it is rigged, it is. So the timer's running again. Okay, so, oh, and 18 minutes left. 18 minutes left. How many nanos do we still have left? So we have to subtract the 3 from Wenderson. So we have 6 now. Did we get more donations? No, 1, 2, 3, 4. Yeah. We only sent out 4 nanos so far. Oh boy. Okay. Then let's speed it up because we only have 17 minutes left and we have 6 nanos left. Okay, so let's just immediately spin again. Neosh, congratulations. There you go. Timer is running. So where was I? Where was I? I moved stuff to the WebSocket server, I think. No? Where else? Was it the session? Oh, I'm lost. No, vote received. Was it the vote received? No. Oh, I lost it. Where did I... Was it... It was the vote received, wasn't it? No. Yeah. Vote received. There is no vote received anymore in Message Builder. It was the vote received. So let's delete that and let's import that. Okay. So same here. Let's inline the topic. Let's inline the message. And let's move this here into the vote code itself. So let's say import vote code as per like that. Okay. And now we can use... Let's remove those things. Now we can use this here. So vote code will be as code AS. Code AS. And we can just inline it. And let's rename the vote A to vote. And let's rename code A to vote. And does this have to be an arc? No. So let's change that so that it does not need an arc, so just a vote reference. So is that okay still? I think so. Okay. Next one. Oh, I missed messages. Jubu Getting Rich says, Craptor41 says, I think there were at least 3 timer restarts without wheel spins. Really? Timer restarts without wheel spins. Oh boy, I really feel that I did not sleep much. I really can't focus today. Then let's just respin the wheel again. 1 nano for... Niyush again. The rigged wheel. So that leaves us with 4 nanos and 12 minutes. Okay, so where are we here? Work generation. Who uses work generation? Oh, only FFI. So I think that then that this is used in the distributed work factory. Yeah. So where can we move this? And this is the last message. So maybe let's rename this to work generation message. And let's not have it in a struct, but let's just have it as a function. Like that. And that means we have to change this to this. And let's remove the result. Here, let's remove the result. And let's go down there and let's do it like that. Let's inline the topic. Let's inline that. Yeah, and while I'm at it, let's also just rename all of these arguments so that they don't have an A suffix anymore. Okay. And this still is very big, this function. What is that? Work request, version, root. Maybe we could... Oh. Maybe we could move this as into like the new function, so that we could say work request new. Difficulty. Quest multiplier, let's rename that. Result multiplier, let's rename that. Result difficulty. What is this? Work result, work request. So all of this is just work stuff. What about the stopped election here? Oh, I forgot to delete this because I copied this over. And I should have deleted it here. Oh, and a lot of unused imports now. Like that. So this simplifies a bit here. Okay. Good, chat. You know, I'm feeling so tired today and I really can't focus. Let's call this a day and let's run the tests. Let's build this. Let's run the tests. Let's push. Oh, what's that? No message builder in WebSocket. Bootstrap attempt RS. Bootstrap attempt RS. Here. No. Was it in the FFI? Again. Bootstrap attempt RS line 4. Okay. Process live dispatcher. Okay. Okay, while this builds, let's spin the wheel. Wenderson! Congratulations, Wenderson. So you get 1 nano back after sending me 3. Does the build say? Okay, there's an unwrap too much in websocket mod RS. Oh, what's that? Too many imports. Message builder. Or was it the other mod RS? No. Yeah, the unwrap is too much. Can't fail anymore. Okay, and let's just spin the wheel just one more time. So this is now going out really quickly. Craptor. 1 nano for you. So now we have 2 nanos left to give away. We are still compiling, so let's just spin it one more time. 1401. Oh. 1401, 1 nano for you. So now we have just 1 nano left, so let's wait until the compilation is over and send out the last one, and then let's call this a day. And maybe we will have a full Rust node in less than a couple of weeks. Yeah, just 2 more classes to port, and then to port the nano node class. And then we are through. And then I can focus my time on cleaning up the code and writing unit tests. And also to port the upstream commits. I mean, look at that, chat. Look at that. It is horrible. 174 commits behind. So that will be at least a month of work to merge them. $14.01, a win on the rigged wheel is a double win in my book, thanks. Yeah, it's a shame that the other wheel doesn't work anymore. So this keeps on compiling. Yeah, I think this will compile to the end. Let's give away the last nano and let's call this a day. The last nano of the day goes to LFLF. LFLF. 1 nano for you. Okay, guys. Yeah, so today's stream was a bit slow and a bit unfocused. I'm sorry for that. I will go to bed and get my night's sleep, and we'll be back fresh next week for the next developer stream, Tuesday, 7 p.m. UTC. Hope you had fun. Yeah, and have a great week, and see you next Tuesday. But guys, bye bye.